And welcome back. We're now covering secure authentication with Windows.
Hello.
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 I wonder if they're going to do like Windows Hola in South America and Spain.
I don't know.
That'd be
Windows, bonjour.
Bonjour. That sounds good.
I don't think so.
Not.
No. So we are talking about secure authentication with Microsoft or Windows LO. Big topic since Ignite was shown. It was like, okay, your face is now your password and biometrics, but it also created a lot of questions. What about if I take a picture? And what about, like, so we'll talk about all that in this session.
The image of Yoda comes to mind, and could I log in with a picture of Yoda onto your account?
No. I know we may look the same, and we may be just as wise. And the force is strong with me, but no, I'm not Yoda.
And just as short.
And no.
And just as old.
Okay.
I just got that one. There you go.
So shared secret, because so far what we've had in terms of password or ways of authenticating was a shared secret method.
Yep.
And as I think it's De Niro that said that in a movie, the only way two people can keep a secret when one of them is dead. So you have something that is easily breached and stolen and phished because you have the secret, but you're also sharing that secret with the server. So if it's lifted at either side, then it can be compromised, breached, replayed, through phishing, and so on. So shared secret, not typically the best. And we've learned from our NTLM background and all the authentication methods we've had since then, how to mitigate that.
We've heard the stories, right? And users, sometimes forget their passwords. My favorite story is one guy actually, when he sits in his cubicle, he looks up at the ceiling tile and his password is printed in pencil in the ceiling tile, right? Or we'll have the RSA key taped to the monitor, right? How secure are passwords at the end of the day, right?
Well, no, they're not very secure, and especially since most users can only remember, it's been proven, and it's like a brain chemistry thing that we can remember 5 digits easily, or 5 characters / digits easily, plus or minus 2.
Yep.
So that's probably why our phone numbers are 7 characters, so we can remember them easily. But now when we add complexity to that, we add complexity to upper, lower caps, special characters, alphanumeric, making it longer, changing it more often, then the users really become not confused, but annoyed with it, and they basically take the least path resistance. So they'll write it, copy it on the back of a sticky note and put it under their keyboard, or tape it to the monitor. This is different though, because this is a shared machine, so we all have to get on.
Or the new trend now is they'll take a picture of it with their smartphone. Of their password.
Yeah, now it gets saved into OneDrive or wherever on social media, and everybody, like threat leaks, we talked about that.
Yep.
So how do we address that in Windows 10? So we're introducing Microsoft Passport. And the role of Passport is to replace the passwords with a private key that's made available through a gesture. So the gesture can be, we say gesture, but do the air quotes next to it. It's a PIN with Windows LO, a remote device, a two-factor authentication, and so on. So that's it's a key that's made available through that gesture. It'll be supported both local password and password to go, so for phone, USB dongles, and so on. So that'll basically follow you around. And it's introduced because of its convenience, the first to do a security first type of environment, where it's at least as good as the password, but be a lot more convenient in terms of the user experience. So you walk up to a machine and your fingerprint, your iris, your face, or your voice becomes your second factor authentication.
Your heart rate, Microsoft Band.
Well, I don't know if you can use that as a password, but
it's a possibility.
It's a possibility. Everything's possible.
Everything's possible.
So right now, using passwords for the credentials, it's to IT, it's a familiar way of doing this. So it's based on asymmetrical keys. So the private key and the public key. So to use the users, it's familiar. It's Windows Hello. They get their PIN or gestures. So it's not very complicated. Very low friction on the user end. It's proofable with OTP, so one-time password, with code and phone factor in terms of you can try to do the gesture and get the prompt for on your phone to say authentication. Put in a PIN. And it does use public key for password is mapped to an account. So your public key is mapped to the account. Your public key is then sent out, and then you can prove that when you log on to a machine that you are you say you are by providing your claim that is signed with your private key and so on. So we'll talk about that a little bit more later. So the keys are generated in the hardware, so it's generated in the TPM, which again, as we mentioned, is not just somewhere we store keys.
Correct.
It is a TPM or a trusted platform. It is a crypto processor. So it allows you to create the keys securely. You can do software as a last resort, so software TPM, but hardware TPM is there. So they're hardware-bound keys, and they can be attested. And what we mean by attested is attestation is a way to prove to the authentication authority that the key that you have was actually created in a hardware TPM key chip. So that level of assurance from the authentication repository will be that much higher and actually allow you for the access that you're requesting. So you single unlock the gesture to provide access to the credentials, and then and we're also working with browser the IEEE, the organization that deals the web standards, in order to make sure that the JavaScript web crypto APIs can be available in all major browsers to allow for that to be used. And the way it works, so the authentication for orgs and consumer, so first you create your account and you prove your identity to your IDP, so your identity provider. Should it be Active Directory, Azure Active Directory, or a Microsoft account, or any other ID provisionable? Yeah. Then it creates and trusts that unique key that's authenticated by validating and the signed request. So you're sending that signed request, and it sends you back your authentication token. It stores it on your machine, and then once you're trying to get to either your intranet resources or other intranet resources, you've already got that key that's trusted by the environment. But you have to unlock that identity using that PIN or your BIO. So your face becomes your second factor authentication. Well, your face, your thumbprint, your voice,
whatever
your
you
iris scan, like your biometrics becomes your second factor authentication.
And it's immersed in the OS. It's not a
built into the OS. Yes. So we look at the hardware keys. So in TPM, you have containers. So you can have a default container where your Microsoft accounts certs will get created and stored. If you're on multiple. If you're connected to multiple IDP, so ID repositories, you can get that. And then, because IT, we like to do things separate. We like to separate all of our identity and everything from everything else, from the consumer. So the kind of the containerization that we talked about in Module 5 today. So in the TPM, there will be an enterprise container in which you can put your enterprise IDP. So that's in TPM right now, and there are hardware secured keys that are stored there. But how does that connect with Hello? So Microsoft Hello. We know that a baby can identify its mother's by the time it's 1 month old, just by recognizing facial features. Most devices can't do that. They're not smart enough. They don't have the instinct. They don't have the senses that we have. They don't operate in the digital world. Well, that's changing. With Windows 10, we do have support for biometric, that will introduce systems for authentication using your face, your iris, your fingerprints to unlock your device.
Yep.
It's convenient, so for users, low friction, works really well. And it does provide strong user authentication, so it's not just a password written on the sticky note
Yep.
or on the ceiling tiles, as you mentioned. It does comply with enterprise level security. It accepts high business impact data via the Microsoft Passport, and it's consistent across all Windows-enabled biometric devices. So what are the biometric steps that you have to take? First, you have to enroll yourself. In the old days, when you had the fingerprint enrollment, you have to sit at that machine and say, okay, put in finger 1,
Yep.
finger 2, finger 3, finger 4, and then do it again. Which finger are you going to be using?
I remember doing that.
You remember doing that? You had to do it over and over and
Yep.
over again, and it would basically store the template of what that fingerprint was. Same thing that we have now in Windows Hello
Yep.
is the machine will actually find your face, and using some algorithm will define and discover specific landmarks on your face and map those. Then it actually looks at the orientation of your head, because you may be tilting one day or tilting the other end of the day,
Yep.
or maybe the machine is on a slant, like you don't know. So it actually does a kind of detection of your head orientation in order to use those landmarks and that orientation to build a secure vector-based template. And it is vector-based because as your head moves,
Yep.
the vectors between all those landmarks will adjust in order to make sure that it works. So it stores that in the template.
And what's interesting is that technology was brought in from Kinect on Xbox.
Yes.
So, while it's a gaming unit, there was other, methodologies in place to test that type of authentication.
And there's even more in terms of Connect and camera-related
Yep.
issues that we're going to talk about in a little bit later. So in the usage, now that I'm enrolled, I want to use it, so I walk up to a machine. The machine will actually find my face, okay, boop, finds the face, discovers the landmarks, detects my head orientation if I'm leaning one way or another, will build a vector base based on what I have now, and then we'll compare it to the template that's stored.
Yep.
Okay, it's not always 100% assurance, because, well, maybe you went out last night and got a little out of control and you fell down and you've got
Black eye.
a black eye or a scratch on your face. That may change, but it has a level of assurance
Yep.
that will say whether or not, yes, it matches or not.
Something as simple as growing facial hair.
Actually, the Microsoft Hello does compensate for that.
Oh, does it? Okay.
Facial hair, makeup, eyeglasses, and so on.
Oh, so it will detect you when you're mascara on.
And my wrinkles, yes.
Your wrinkles. I didn't say anything about wrinkles, just mascara.
I knew it was coming, so I'm
wasn't
beating
going
you to
there,
the punch.
but
I'm
that's
beating you
okay.
to the punch. Also, when it does find a face and it does not match the template, so you can try it multiple times. After a while, it'll just say, hey, I just want to make sure that it's you, so put in your PIN. So now you have to revert back to the PIN to match, because, yes, it may come to a point where it's not recognizing you. Maybe you're not standing the right way. Maybe it has nothing to do with lighting, first of all. We'll talk about that in a bit.
Oh, okay, cool.
So you could do this in complete darkness, and it would still work. And then once your PIN is done, it verifies your PIN to verify your identity. So it always makes sure that the users that's authorized can connect and do their work. So it'll try. If it fails, then it comes back. And so that brings me to the point of authentication versus identification, because those are two different things.
Yes.
You identify a user and then you authenticate them. So not every biometric modality is created equal.
Yep.
So if you're looking at, there's a number of things that can happen in terms of false acceptance rate. So you get 1,000 faces, and maybe there'll be a percentage of faces that get accepted when they shouldn't be.
Yep.
But again, there's the other end of that coin, the other side of that coin, where you're going to have false rejection rate.
The other side of the toonie.
The other side of the toonie for us, where even though you are the right person, it's not recognizing you.
Yep.
And of course, in biometrics in Windows 10 with Microsoft Hello, we have liveness or anti-spoofing. Well, I can talk about that in a minute. Actually, let me jump right that to there. So anti-spoofing or liveness, anti-spoofing. So you look at the screenshots that I have here, and as you can tell in terms of the school portrait. So if you're trying to log on as somebody and you bring in a picture of them and you stick the picture in front of the camera, what's on the left is what the camera actually sees. What's on the right is what's actually being presented to the camera.
To the camera.
Because the bad news is your existing webcam or the existing webcam in your laptop will most likely not be supported.
Right.
Because it doesn't have IR capabilities that need to detect that spoofing media. So if we go back to the slide, we look. The portrait is blank because the IR there's no
recognition.
There's no recognition. There's no body heat. Nothing. The same with the middle picture where you're actually putting a Lumia or a Windows phone up to the camera with the pictures of somebody, or even a tablet. You could have all the resolution you want. The IR is not actually going to be able to recognize it, which also, because of the IR capabilities, allows you to do this in complete darkness. So it's like, have you ever seen the videos online of somebody with a night vision goggles looking at a room where a Kinect is turned on?
No, I haven't seen that. That's actually cool.
Seen that?
No.
Yeah. So you see all the IR dots on the walls, and the capture, it picks up all those dots to identify
cool.
3D modeling. So that's pretty cool. So if we go back to the requirements, so in terms of the security requirements, so we have to demonstrate that the false rate of acceptance is 1 in 100,000. So we have to make sure that it's really, 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 really low in terms of being able to say false acceptance, and that being your second factor authentication.
Not singular. Not you're doing multi-factor.
Yeah. So and the false rejection rate to be 2 to 4, less than 2 to 4%. We have to provide liveness. We just talked about that, and anti-spoofing.
So you can't log into my machine with the picture of an Ewok anymore.
No. So the face authentication, in terms of how we've trained the service to do that, is we've to learn that 1 in a 100,000 face accept rate threshold. We actually presented like 4.3 million test combinations of faces. And machine learning, based on that accuracy thresholds, they validated against all these faces. So we had to use a fairly large representative sample to basically train the system, using mix of ethnicity, height, weight, skin color, glasses, and so on. And we captured that on reference hardware. So biometric is as a second factor. So not only your system will authorize your use of Microsoft Passport keys when you submit the matching biometric sample at the moment of authentication, and the system will use that and make sure that the sample is live. So for those of you who have watched movies where they cut off somebody's finger in order to use that's not, it won't work, because the sensors have in them the capabilities to detect that this is an actually live body part. So our fingers, once we go to biometrics, our fingers are all safe. Don't have to worry about that. And our goal is to make biometrics non-susceptible to spoofing attack, to attack of privilege codes, and offline attacks of any kind. And the way we've done that is by building a biometric framework right into Windows 10. So we have this framework that it allows to abstract the specificities, I don't know if I'm saying it right, of the biometric modality. So how each biometric modality is different or is unique from one to another. So whether or not it's fingerprint, your voice, your face, your iris, and it isolates that and abstracts those in order to provide that to the framework that will pass it on to the Windows biometric service provider, the engine adapters, and the sensor adapters to provide actual recognition.
And this is available amidst the OS. This is not a bolt-on.
This is not a bolt-on.
Resource hog. You may require additional hardware, because as we mentioned before, the camera on your Surface would not be able to do this type of functionality.
Yeah.
However, what's great is that once you have the drivers loaded for that hardware.
Well, the only part that's not bolted on,
Yep.
that is bolted on, is that the third party. So if you're getting a camera
Yep.
that has its own device, driver, and that its own engine adapter.
But that's it.
But that bolts into that.
Yep.
But that passes the information into the biometric service. That passes it on to the client APIs, then to the OS itself.
Yep.
So.
Hey, capitalizing on docking stations in a secure environment, when I take my Surface, pop it into my docking station, the iris scanner could be connected to my docking station and allow me to authenticate through two-factor authentication through Hello.
Yeah. So when we look at Windows 10 and Windows Hello with Iris or Face or other types of, it's in-box functionality, and it will work across a variety of devices running Windows 10. As long as the hardware, like the cameras, have
Yep.
the IR and capabilities, or the drivers for that. It's integrated anti-spoofing countermeasure to mitigate those attacks. So the gummy bear, have you ever heard of the gummy bear attack?
Yes, I have.
Gummy bear attack on fingerprint readers, where you play with the gummy bears and it leaves a residue on your fingers, and you can actually extract or harvest fingerprints from other people. I don't know how much stock I put in that, but this, with the newer biometric sensors, that won't happen. Consistent image via IR, so regardless of lighting. So here in this studio, we have really good lighting. In my office at home, I have okay lighting. And tonight, when I'm on the plane going back home, I'm going to have really bad lighting.
I'm sleeping.
I'm going to be working. So the IR kind of levels that playing field, and it allows for subtle change in appearance. So when you do finally shave that beard, Microsoft Hello will still recognize you.
As ugly as
you
I
won't
am.
get any prettier, but at least Hello will recognize you. Well, I got to do it. So whether or not hair, makeup, eyewear, and so on.
Foundation,
Yes.
blemish cover-up.
I did have a zits, and I covered it up. So in summary, Windows 10 is moving the world into a more secure and password-free. So no more of the shared secret and experience, and it's powered by Passport and Hello. Available, built-in, out of the box in Windows 10. It'll introduce support for biometrics with any kind or multiple kinds of sources, faces, iris, fingerprints. Convenient, low friction for the users, high assurance for the IT world, and it will be consistent inbox for and users experience across the board for every device.
And remember, this is a platform play, so it's Windows 10 cross-platform. Xbox will be running this as well.
I haven't heard anything about that yet, but
It's
to be validated.
To be validated, but if that possibility does come into fruition, what a great way to secure, the platform as a whole.
Yeah. So lots of value in there for you guys. Lots of enhancements in terms of user experience and security at the Microsoft at your enterprise side. So it's a win-win for everyone.
Yeah. So that's the end of this module, secure authentication with Windows Hello.
Yeah.
Stay tuned for Module 8.
Yeah, we got one more to go, and let's get to it.
See you soon.